Time for Lewis dots. Okay, Lewis dot diagrams are just easier Bohr diagrams. Bohr models, that's what I mean to say. A Bohr model gives you the thing in the middle with all the rings, all of them. And like, you don't really need those, you know? If you've got something like iodine, which has a ton of rings, you really don't need to know about anything but the last one, okay? So, iodine, for example, it's a member of the halogens, like chlorine, so it's going to have 7 dots on the outer ring, 7 electrons. So, for Lewis dot, we just indicate that by dotting as though it were a ring around our little symbol, so 7 dots. So pair them up, and there we go, 7. Of course, the dot by itself could be anywhere here. You know, it could be here. I could erase this one and put it there, blah, blah, blah. It doesn't really matter where that empty guy is. And so sodium, for example, right, it's going to have 1 on the outer shell, so just 1 dot. That's basically how easy it is. They're really simple. Mg, 2+. And look at the table, because you can understand, sorry, my screen starts flickering and stuff. But you can understand using the table. Sodium's over here, right? It's in the first column, so it's going to +1. It's going to have 1 on the outside. This magnesium, second column, it's going to have 2. You know, same thing with calcium. It's going to have 2 on the outside. And then you kind of skip the yellow area, this area in between. Skip over here, you know, out over to oxygen or sulfur. It's going to have 2, 1, 8. You know, that one's full, or empty, I guess, if you think about it from the other direction. 3, you know, like it makes sense using your table, okay? So, yeah, you can just glance at your table and kind of understand how that works, how many dots are going to be on the outside. So, like, sulfur is going to have 2. Oxygen is going to have 2. Now, Lewis dots become more handy and kind of more difficult when you want to imagine things reacting or connecting with each other and things joining to form compounds. So if you have lithium, and look that up on your periodic table, it's in the first column, it's going to have 1 dot, okay? I don't like that that's next to there, but just imagine it's not. So it's going to have 1 dot, so it's got 1 electron to pair, and I'm actually going to move that because it's frustrating me. It's got 1 electron to pair. I'm going to put it over here. And then let's say there's chlorine. Chlorine's got 1, 2, 3, 4, 5, 6, 7. Okay? Try to put these dots so that they can hook up. So basically, they're going to share. That guy's going to go over here, this guy's going to go over here, and they're going to touch. So you end up with a handy dandy this kind of situation, so that this is a full ring, and this guy's happy as well because he's involved in the full ring, and you know, everything's satisfied, everything's good, everything's golden. That's basically it. That's how you hook them up. So let's try another example. Calcium, it's got 2 little dots. And let's look at bromine, because it's got 7. Or let's look at sulfur. No, I'm going to do bromine, because bromine's got 7, like chlorine. Okay, so that's going to hook up there, that's going to hook up there. And then you notice, I'm going to redraw this electron somewhere else. Sorry, I erased something. You notice that this one's still unhappy. 1 bromine is not enough for this calcium. It's very needy. And so you're going to need another bromine down here. That way, this is going to hook up with the calcium. It's going to hook up with the bromine. Now you're all satisfied. So, CaBr2. Can you make that connection? Does that make sense? Your calcium, in order to be satisfied, not just 1 bromine, it's got to have 2. Because the electron, all the dots have to kind of, you know, pair up nicely. And then that means your formula is going to end up like CaBr2. our lithium and chlorine is just going to be LiCl because they just needed one. Yeah, so that's basically it. It's Lewis dots are either like that by themselves to show you the outer ring, or you can even demonstrate how they would connect with each other. And it's probably better for me to look in the provincial exam for some examples, so if you guys are still stuck, just let me know and I'll go over a few.